Alrighty, you guys, we are going to talk about Unit 1 FRQ test examples. Number 1 here, the first question, we are going to graph this cubic. So to graph this cubic, you first want to know H is going to be 3 because it's the opposite of that. K is going to be -2. So 3, -2 is your HK, which is the center of this cubic graph. The number in front is your A value. The A value is 4. What that means is from this value, you're going to go over 1 and up 4. And then over 1 and down 4. That is the power of the A value, it's a vertical stretch. Now right here we have a polynomial we're going to graph. And what we do here is we first look at the zeros. So what would make this 0 is 0. What makes this 0 is 4. What makes this 0 is -4/3. How do we know that? We solve it right here. So if you solve this at equal to 0 and solve, you get -4/3. All right, now why did I say multiplicity here? Because do you notice that this one right here has a squared on it? So that means it's going to be a bounce off, called a multiplicity. Same here. So both these are going to be a bounce off, called a multiplicity. And then up in front you have a 2. This 2 up front is your A value. It tells you in behavior, or helps with in behavior. So with that said, we know because this 2 is going to go up on the right. So I know it's going to go up here on the right, all right, because it's a positive A value. All right, so I also know as we hit right here at 4, we said it's a multiplicity, so we knew it's going to bounce off. All right, so as we come to 0 here, which comes with this one, which isn't a multiplicity, so it's not a multiplicity right there. So that means it's going to go straight through. We got to turn around. So once that approaches negative, this is not -1, this is -4/3, which is -1 1/3. And that's a multiplicity, so guess what? As you come back to that, it's going to bounce off. So that's how we kind of sketch it. We kind of look at the right side and work our way through if it's a bounce off or a straight through. So these are bounce offs, multiplicities, and these are straight throughs. And you also double check because this is an odd power, odd degree. We know it's an odd degree because this is x times x twice, so it'd be x times x squared, which is x to the third. And then times 3x times 3x would be x to the fifth. So this is actually a 5th degree polynomial, which is odd. That's another way to kind of help you out with that. Lastly, we want to find what is the remainder. Now you could do long division. I skipped it. There are 2 other ways to find your remainder. One of the ways is simply plug in what makes this 0. So I plug in -3. And as you can see right here, I plugged in -3. By the way, I also put it in standard form. You don't have to put it in standard form. I did. I just wanted to for some reason. Okay, so when you plug in your -3, what makes that 0? You do the math, that becomes -27. That becomes 9. And as you break this down, that's +27. This becomes a -18, and then those right there add up to be 9, and then 9 plus 4 is 13. So that is one way of doing that. That's just one particular way. Because in order to find the remainder, you're finding basically whatever makes the 0 and plugging it in. The other way, oh, by the way, that's called remainder theorem. The other way is to do division with a synthetic approach. So what we did is we took that -3 again, and we put the coefficients of this. So the coefficient of x to the cubed, we put it in standard form, it's -1. This would be -2x squared. There are no x's in this, so it would be 0 x's. And the 4 is the leftover unit digit. So this is again -1x cubed, -2x squared, 0x, and 4. All right, with that said, we now have the -3 in the corner, and we bring down the -1. -3 times -1 is 3, add down. -3 times 1 is -3, add down. -3 times -3 is 9, add down. Same answer, both ways to get remainders. You can choose which way you want. Good luck with this.